హలో ఎవ్రీవన్, వెల్కమ్ టు సాయిమేధ కోటి హైదరాబాద్. ఈ వీడియోలో క్లాస్ నెంబర్ 5 ఇన్ ట్రాన్స్ఫార్మర్స్, దట్ ఈస్ లాసెస్ ఆఫ్ ద ట్రాన్స్ఫార్మర్. ఇన్ దిస్ టాపిక్ I will discuss about short notes and concept through question, and this class is useful for Andhra Pradesh State Electricity Board exam, board AEE exam, and also Telangana genco transco discom AE exams. The topic is classes of the transformer. So this is the class number 5. Already we have discussed 4 classes, and continuation class number 5 is losses of the transformers. Initially we will discuss about short notes, and after that we will discuss about concept through questions. So let us solve some question based on this concept. Through questions we will discuss the concept involved in that question. And first one, short notes. So short notes in losses of the transformer. So these short notes sometimes you can call key points, okay, key points or observations from the losses of the transformers, or possible questions from losses of the transformers. So whatever the name it is, so all key points, observation, short possible questions from losses of the transformer. And what are the various type of losses? First question is, first observation, what are the various type of losses in transformer? Okay, in transformer, see here, what are the various type of the losses in the transformer? First point, various type of losses in transformer. So there are 4 type of the losses in transformer. One is first one is copper losses of the transformer. Copper loss, okay, it is denoted by WCU. And next, second losses is a iron losses, or so this iron loss, and another name of these losses, copper losses, iron losses, are core losses of the transformer. It is denoted by WI. And these iron losses are 2 types. One is hysteresis losses of the transformer. Hysteresis loss of the transformer, it is denoted by WH. And the second one is eddy current losses of the transformer. Eddy current loss, it is denoted by WE, eddy current losses of transformer. And next, one more type of the losses, that is third one, stray load losses of transformer. And these stray load losses also 2 types. One is the stray load copper losses of transformer, and second one is the stray load iron loss of transformer. Stray load copper losses are stray load iron and all stray load iron losses of transformer. And fourth type of the losses is dielectric losses of the transformer. Dielectric loss of the transformer. And these 2 losses here, okay, this one is copper losses and iron losses are major losses of transformer. These are major losses of transformer, major loss of transformer, and it is in the percentage of 99% of the losses. So in the 99% of total power loss, 99% of the total power loss, ఒక మొత్తం పవర్ లాస్లో 99% ఉంటాయి. కాపర్ లాస్ అండ్ ఐరన్ లాస్ రెండు కలిపి 99%. అండ్ దీస్ 2 losses are treated as minor losses of the transformer. Minor loss of transformer, and it is less than 1% ఉంటుంది. So 1% of the total lossలో less than 1%, the less than the 1% of the total losses. And copper losses, depends on the load current or load variation, and that's why these copper losses are treated as variable losses of the transformer, variable loss of transformer. And iron losses are independent of the load current and load variation, so that these losses are treated as constant losses of the transformer, constant loss. And stray load losses depends on the load current and load variation, so that these losses are treated as variable losses of the transformer. And next one, dielectric loss, it is independent of load current and load variation, so that's why these losses are treated as a constant, the losses of transformers. So this was the discussion about losses point of view. There are 4 type of losses. One is copper losses, iron losses, stray load losses, and dielectric losses. And total constant losses is equal to iron losses plus dielectric losses are treated as total iron losses, and copper loss and stray load losses are treated as total variable losses of the transformer. And sometimes we have a question that what are the variable losses in transformer, and what are the constant losses in transformer, what are the major losses in transformer, and what are the minor losses in transformer. So it is a percentage point of view, it is a 0.5% of total loss, 0.5% of the total loss, and this losses is 0.25% of the total losses, and combinedly it is a less than 1% of the total loss. That's why it is known as a minor losses of the transformer. These two are treated as major losses of the transformer. And next question, another observation here, in this case, another observation, second observation, and in this case, how to calculate full load copper losses of transformer. Sometimes we have a question, how to calculate full load, okay, this full load, FL is nothing but full load copper losses of the transformer, copper loss of transformer, and it is equal to I1 square R01 and is also equal to I. So first one, total copper loss of transformer, copper losses in the primary winding plus copper losses in the secondary winding of transformer, and this I2 square R02. So this also equal to I1 square R01, it is also equal to I2 square R02. So this is the formula to find out the total copper losses of transformer. And next, another possibility of the question, copper losses of the transformer at any x of the load, where x is a fraction of the load, and for example x is equal to 1 for full load condition, x is equal to 1 by 2 for half full load condition, x is equal to 1 by 4 for 1 by 4th full load condition. And this one is first one, copper losses of the transformer, copper loss of transformer at any x of the load, any x of load. So this x of load is equal to the x square into I2 square R0, x square into full load copper losses. You can write x square into full load copper losses of the transformer, and in the short form it is also right, x square is equal to I2 square R02. So this is the copper losses at any x of the load. So in this case where x is equal to, so x is equal to 1 for full load condition, x is equal to 1 by 2 for half full load condition, and x is equal to 1 by 4. So for 1 by 4th full load condition, so 1 by 4, and x is equal to 3 by 4 for 3 by 4th full load condition. So these are some observations, third observation. And next one more question, copper losses at any x of the load, and another possibility of the question from this concept, that is fourth one. See here, fourth one, there is a question like this, per unit copper losses of the transformer. How do we calculate per unit copper losses? Per unit copper losses of the transformer is equal to per unit copper loss of transformer, so is equal to, so per unit voltage drop of the transformer, and this is also equal to per unit resistance of the transformer. So per unit resistance of transformer. Suppose if you want to find out percentage copper losses multiplied by 100. So percentage copper loss is equal to percentage voltage drop, that is also percentage resistance of the transformer's point. So this is also another possibility of the question. And copper loss depends on the load current. And what is the relation between copper losses and load current point of view? Copper losses of the transformer, the directly proportional to square of the load current. This is also one more question. Copper loss is directly proportional to the square of load current. So this I2 is nothing but the load current. So this is about the observations from the copper losses of the transformer. And next possibility of the question, that is the sixth one. Sixth possibility of the question. Iron losses point of view. Iron losses are directly proportional to the square of the applied voltage. Iron loss always directly proportional to square of the applied voltage, where V1 is the applied voltage of the transformer. Iron loss directly proportional to square of applied voltage. And iron loss, total iron losses is equal to, so total iron losses are per unit. Sometimes we have a, first one let us calculate the total iron loss of the transformer. Iron loss of transformer is equal to hysteresis loss. Iron loss is denoted by Wi. So it is equal to hysteresis loss plus eddy current losses. So this is total iron losses of transformer. And sometimes another possibility of the question from the losses, per unit iron losses of the transformer. Per unit iron loss of transformer is equal to, how do we calculate per unit iron losses? Per unit iron losses is equal to total iron loss divided by VA rating of the transformer. VA rating of transformer, say, per total iron losses and VA rating of transformer. So total iron losses in watts, ఒక ఈ వాట్స్లో తీసుకోవాలా, అప్పుడు VA రేటింగ్ తీసుకోవాలి. ఒకవేళ కిలో వాట్స్లో తీసుకున్నప్పుడు ఇక్కడ KVA రేటింగ్ అనేది తీసుకోవాలి. క్యాల్కులేషన్ చేసేటప్పుడు సపోజ్ iron loss are given in the kilowatts, here we have to mention that KVA rating of the transformer, total iron losses of the transformer. And another possibility of the question, what is the formula to find out hysteresis losses? And hysteresis loss is equal to, is equal to area of one hysteresis loop, area of one hysteresis loop or BH loop, hysteresis loop multiplied by the number of hysteresis loops, that is nothing but frequency. So this is a formula to find out the hysteresis loss of transformer. Sometimes based on this formula also we have a questions. Area, how to calculate hysteresis losses is equal to area of the one hysteresis loop multiplied by frequency. And next one, the here hysteresis losses, losses of the transformer, loss of transformer, and it is denoted by WH. WH is equal to here KH is the proportionality constant, B maximum power of 1.6, here actually X here, and this is the B maximum power of XF multiplied by V. So this you can write KH B maximum power of 1.6 F multiplied by V, where F is a frequency, V is a volume of the transformer core. So in case 1, see here the hysteresis loss in the case 1, where case 1 I can say that when B maximum is constant, so now this condition, so hysteresis loss directly proportional to, B maximum is a constant, hysteresis loss directly proportional to the frequency. So this formula important, the hysteresis loss directly proportional to the frequency. And case number 2, so that is when B maximum is not constant, B maximum is not constant, and this hysteresis loss directly proportional to V1 power of 1.6 F power 0.6. Okay, this is the hysteresis losses point of view. The hysteresis loss, okay, here this WH directly proportional to the frequency, and when case number 2 WH is V1 power of 1.6 and F power 0.6. Okay, and eddy current losses. Next point, eddy current. How do we calculate the eddy current losses of the transformer? 11th one, how to calculate? So eddy current losses of the transformer. So it is denoted by WE. How to calculate eddy current losses of the transformer? So that is KE B maximum square, the F square and T square. B maximum is a maximum flux density of the core, and F is the frequency, T is the thickness of lamination. And during the designing here, so this condition is, okay, these two conditions are valid during operation, okay, during operation. And suppose during the designing, hysteresis loss directly proportional to volume of the core, So now note here, so during designing of the transformer, designing of transformer, the hysteresis loss directly proportional to volume of the transformer core. So this is also one more possibility of the question. Hysteresis loss directly proportional to volume of transformer core. And here also eddy current losses point of view. So during designing of the transformer, the eddy current loss directly proportional to square of the thickness of laminations. And during operation of the transformer, so during operation of transformer, so this eddy current losses directly proportional to product of flux density square and the frequency square. So here now we have two questions. Case 1, I am assuming here case 1E, and in this case when B maximum is constant, B maximum is a constant, so then what will happen? The hysteresis loss directly, eddy current loss directly proportional to square of the frequency. And in case number 2, okay, case number 2, so when B maximum is not constant, okay, is not the constant, then so here hysteresis loss, eddy current loss directly proportional to square of the applied voltage, the square of applied voltage, where V in the sense, in this case V1 is applied voltage of the transformer, applied voltage of the. These are the two questions from the eddy current losses. During the designing, eddy current loss directly proportional to square of the thickness of lamination. During operation of the transformer, eddy current losses directly proportional to product of flux density square and frequency square. When B maximum is constant, eddy current loss directly proportional to square of the frequency. When B maximum is not constant, eddy current loss directly proportional to square of applied voltage. And next possibility of the question, what about iron losses? Iron losses point of view. Iron loss, how do we calculate iron losses? So we know that iron losses, the Wi is equal to WH plus WE. So there are two cases, iron losses in the when B maximum is constant. First case 1 I am taking. Case 1, when B maximum is constant, then what will happen? So when B maximum is constant, iron losses is equal to, and that is A proportionality constant, and this one is the A into F plus B into, so V1 power of B into F, okay, hysteresis loss plus eddy current loss when B maximum is constant, B into F square. So this is the formula to find out iron losses. When B maximum is not constant, okay, this case number 2, so that is when B maximum is not constant, okay, not constant. How to calculate, okay, these iron losses? Iron losses are is equal to the A into V1 power 1.6 divided by F power 0.6 plus B into the V1 square, where A and B are proportionality constant. A and B are some proportional constants. Simply you can call it as, so we can take A and B are K1, K2, C1, C2, whatever it may be, but I am interested to take A and B. So iron loss when B maximum is constant, iron loss is equal to A into F plus BF square, and eddy current iron losses when B maximum is not constant, iron loss is equal to the A into V power 1.6 divided by F power 0.6 plus B into V1 square, where V1 is applied voltage of the transformer. So these are all possible questions from the losses of the transformer. So మీరు క్వశ్చన్ సాల్వ్ చేయడానికి ఈ పాయింట్స్ నీకు తెలిస్తే క్వశ్చన్స్ని ఈజీగా సాల్వ్ చేయొచ్చు. ఓకే, విల్ డిస్కస్ ఆల్ ద క్వశ్చన్స్ బేస్డ్ ఆన్ దిస్ కాన్సెప్ట్. Let us solve some questions based on this concept losses of transformer. Question number 1. A 220 upon 440 50 Hz 5 kVA single phase transformer operates on 220 volts 40 Hz supply with secondary open circuited. Then both eddy current and hysteresis losses decrease. Option number 2, both eddy current and hysteresis losses increases. Option number 3, eddy current loss remains same but hysteresis loss increases, and eddy current loss increases but hysteresis loss remains same. And here case number 1, see this case 1, initially 220 volts and frequency the 50 Hz, and what will this we can consider is hysteresis loss WH1 and eddy current loss is equal to WE1, so WE1. And what about in case number 2, and applied voltage is 220 volts only and frequency is 40 Hz, so this 40 Hz, then what will happen in the hysteresis losses and also eddy current losses? These are the two questions. First verify the flux density whether it is a constant or not. So let us verify flux density during operation of the transformer. The B maximum directly proportional to V1 by F. By keeping voltage constant, frequency reduces, flux density of the core will be increased, so that B maximum is not constant. Okay, B maximum is not constant one. So when B maximum is not constant, then what will happen? So when the B maximum is not constant, so then what will happen? So what will happen in the hysteresis loss and eddy current losses? When B maximum is not constant, the hysteresis loss directly proportional to V1 power of 1.6 and eddy it is directly proportional, inversely proportional to frequency power of 0.6, whereas eddy current loss directly proportional to V1 square. Now apply the given conditions to get a answer. Apply the given conditions, that is voltage is a constant, frequency is reduces, hysteresis losses of the transformer will be increased, and by keeping voltage constant, hysteresis losses remains the same. So what is the answer? By keeping voltage constant, eddy current losses remains same, and here eddy current losses remain same but hysteresis losses will be increased. So option number 3 is correct for this question. Option number 3, eddy current losses remain same but hysteresis losses will be increases. And next let us solve question number 2. The hysteresis and eddy current losses of a single phase transformer working working 50 Hz supply are PH and PE respectively. The percentage decrease in these when should be 160 volts 40 Hz supply are option 1 32,36, option number 2 20,36, option number 3 25,50, and option number 4 40,80. So initially a given supply voltage and frequency of the transformer is for 200 volts. Okay, single phase transformer. So eddy current losses of a single phase transformer working with PH and P. and here actually there is some mistake in this question, and it is a 200 volts and 50 hertz transformer. Initial conditions 200 volts 50 hertz transformer working with a, so this voltage 200 volts and 50 hertz are having the hysteresis eddy current losses of PH and PE. So 200 volts 50 hertz and the hysteresis losses WH1 is equal to PH and eddy current losses WE1 is equal to the PE. And in case number 2, so that same transformer is operated with a reduced voltage and frequency 160 volts 40 hertz, then percentage decrement in the hysteresis losses, percentage decrement in the eddy current losses. Now to answer this question, first verify the flux density whether it is constant or not. Let us verify flux density. So we know that during operation, of the transformer operation, so this during operation flux density of the transformer directly proportional to the V1 by F ratio, and this you can write B maximum 2 divided by B maximum 1 is equal to V12 by V11 multiplied by F1 by F2. So therefore B maximum 2 divided by B maximum 1 is equal to, so applied voltage in the case number 2 160 divided by 200 multiplied by frequency f 50 Hz divided by 40 Hz. So by solving this we will get B maximum 2 is equal to the B maximum 1. So flux density of the transformer core is remain same. And when flux density is a constant, then what will happen? So when flux density B maximum is constant, what will happen in the hysteresis loss and eddy current losses? The hysteresis loss directly proportional to the frequency, whereas eddy current loss directly proportional to the square of the frequency. Now first case, let us calculate the eddy current losses and hysteresis loss. WH2 divided by WH1 is equal to F2 divided by F1. So WH2 by the WH2 divided by WH2 divided by WH1 is nothing but, so PH is equal to F2 is 40 divided by 50. So now this value is equal to 0.8. So that is WH2 is equal to 0.8 times of the WH1, that is a PH value. So PH. Now initial value is a 1, final value is a 0.8, and decrement in the per unit value, so is equal to 1 minus 0.8, that is a 0.2, and decrement in the percentage value, so percentage value, always percentage value is equal to per unit value multiplied by 100. So 0.2 into 100, so we will get 20%. So this is the answer for this question. And next another one, eddy current losses point of view, WE2 by WE1 is equal to F2 by F1 whole square. Okay, WE2 by WE1, F2 by F1 whole square. And here how do we answer this question? WE2 by PE, so is equal to F2 is a 40 divided by the 50 whole square. So that is, by solving this we will get, so W it is equal to 0.64 times of the PE, and initial value so is a 1, final value is a 0.64, and so that decrement in the per unit value, so decrement in per unit value is equal to 1 minus 0.64 and it is equal to 0.36, and decrement in the percentage value, so this is equal to 0 per unit value multiplied by 100, so this value is equal to 36%. The decrement in the per unit value is the 0.36, decrement in the percentage value is the 36%. Here also decrement in the percentage value is the 20%. So answer is 20,36% is the answer. ఇలా చేయాలి క్వశ్చన్. అంటే మీరు ఇనీషియల్గా ఏమి ఇచ్చిండు చూసుకోవాలా, తర్వాత సెకండ్ కేసులో ఎలా, ఫస్ట్ ది క్వశ్చన్ సాల్వ్ చేసేటప్పుడు ఫ్లక్స్ డెన్సిటీ కాన్స్టాంట్ ఉందా లేదా చూడాలి. ఫ్లక్స్ డెన్సిటీ కాన్స్టాంట్ ఉంటే కేస్ 1 ప్రకారం ఈ రిలేషన్ వాడాలి. తర్వాత ఎడ్డీ కరెంట్ లాసెస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు the directly proportional square of the frequency n. ఒకవేళ ఫ్లక్స్ డెన్సిటీ కాన్స్టెంట్ లేదనుకోండి, according to the case 2 hysteresis law directly proportional v1 by f v1 power of 1.6 f power 0.6 and it is direct eddy current loss directly proportional to v square అనేది వస్తుంది. సో ఈ విధంగా అడిగే ఛాన్సెస్ ఉంటుంది ఈ క్వశ్చన్లో. నౌ లెట్ us solve one more question here. A 220 volts 115 volts 25 Hz single phase transformer has eddy current loss of 100 watts which is half of the no load loss at rated voltage. If the transformer is used with the primary connected to 440 volts 50 Hz mains, then the total nodal losses would be option 1 300 watts, option 2 600 watts and option 3000 watts and option 4 400 watts. And initial case I am dividing into the two case. Case 1 లో వోల్టేజ్ ఎంత ఇచ్చానంటే 220 వోల్ట్స్ అనేది, తర్వాత ఫ్రీక్వెన్సీ f25 Hz ఫ్రీక్వెన్సీ ఇచ్చాను. సో అండర్ దిస్ కండిషన్లో ఎడ్డీ కరెంట్ లాసెస్ ఈజ్ ఈక్వల్ టు 100 watts అన్నాడు. సో ఈజ్ 100 watts విచ్ ఈజ్ హాఫ్ ఆఫ్ ద నో లోడ్ లాసెస్ ఎట్ రేటెడ్ వోల్టేజ్. అంటే నో లోడ్ లాసెస్ ఈజ్ నథింగ్ బట్ ఐరన్ లాసెస్ ఆఫ్ ద ట్రాన్స్ఫార్మర్. ఐరన్ లాసెస్ ఆర్ టూ టైప్స్, హిస్టెరిసిస్ లాస్ అండ్ ఎడ్డీ కరెంట్ లాస్. ఇది ఆఫ్ అయినప్పుడు ఐరన్ లాసెస్ హిస్టెరిసిస్ లాసెస్ ఆల్సో ఈక్వల్ టు 100 watts, ఒక 100 watts. And this is the total iron loss is equal to 200 watts. Half of the no load losses is equal to eddy current losses are equal to 100 watts and hysteresis losses are equal to 100 watts. Now same transformer is operated with the another voltage and frequency. What is the voltage here? 440 volts, the 50 Hz. Under this condition, what are the total losses of the transformer? Total losses adigaadu. So how to calculate the total losses of transformer? So total losses ela calculate cheyali? First verify the flux density. So B maximum is directly proportional to the V1 by F ratio during operation. This you can write B maximum 2 is equal to B maximum 1 and into V12 by V11 multiplied by F1 by F2 and simplify and so B maximum 1 is equal to, let us take B maximum 1 and V12 is a 440 divided by 220. Frequency F1 is a 25 divided by 50 Hz. So it is 25 into 2 equal to 50 and 220 into 2 equal to 440. So 2 is cancelled, so that you can say B maximum 2. So this B maximum 2 is equal to B maximum 2 is equal to B maximum 1. So B maximum అనేది కాన్స్టెంట్ ఈ క్వశ్చన్లో. B maximum కాన్స్టెంట్ అయినప్పుడు మనకు కావాల్సింది ఐరన్ లాస్ అండ్ ఎడ్డీ కరెంట్ లాసెస్ క్యాలిక్యులేట్ చేయాలి. సో వెన్ B maximum is constant, when the B maximum is constant, what will happen in hysteresis loss and eddy current losses? The hysteresis loss directly proportional to the frequency, whereas eddy current loss directly proportional to the square of the frequency. So therefore WH2 is equal to WH1 into F2 by F1 value. So WH1 F2 by F1. So WH2 is equal to WH1 is 100 and this is the 50 Hz frequency, 50 divided by 25. So now it is equal to the 100 multiplied by 2, so equal to 200 watts. And WE2 is equal to WE1 into F2 by F1 whole square. So therefore 100 multiplied by the 25 by, so that the 50 divided by 50 divided by 25 square. So 100 multiplied by 4, so multiplied by 4. So this one is equal to 400 watts. Now we require total no load loss, total iron loss. So is equal to is WH2 plus WE2 is equal to 200 plus 400 equal to 600 watts. So this is the answer for this question. 600 watts is correct answer for this question. సో ఇలా ఆన్సర్ చేస్తే మీకు ఈజీగా వచ్చే ఛాన్స్ ఉంటుంది. ఫస్ట్ క్వశ్చన్లో డేటాను కరెక్ట్గా డివైడ్ చేసుకోవాలా. డేటా డివైడ్ చేసుకున్న తర్వాత ఫ్లక్స్ డెన్సిటీని వెరిఫై చేయండి. flux density constant ఉందనుకోండి, then use the conditions. So to get the answer, let us solve question number 4. A transformer fed from the alternator at 230 volts 50 Hz has eddy current losses of 50 watts, hysteresis losses of 100 watts. If the speed of the prime mover driving the alternator drops to 80% of its previous speed, then eddy current and hysteresis losses in the transformer would be respectively option 1 40 watts, 80 watts, option 2 32 watts, 80 watts, option number 3 32 watts, 64 watts, and option number 4 640 watts, 64 watts. And initial case, in case 1, applied voltage is equal to 230 volts and frequency is equal to 50 Hz. Under this condition, hysteresis losses of the transformer is equal to hysteresis loss 100 watts and eddy current losses of the transformer is equal to that eddy current losses of the transformer 50 watts. The hysteresis loss and eddy current losses of the transformer is equal to 50. In case number 2, so frequency here mentioned that if the speed of the prime mover decreases to 80% of its previous speed. So it means that when speed is equal speed of the alternator 120 F by P. So now this 120 F by P, where F is equal to so Pn by 120. So F is directly proportional to the speed. When speed is reduces, frequency also reduce. And what about voltage? Voltage also the directly proportional to the frequency. When voltage reduce, this frequency reduces, voltage also reduce. It exactly drops to the 80% of previous one. So it means that here V12 is equal to 0.8 times of the 230 volts and F2 is equal to 0.8 times of 0.8 times of the 50 Hz. So this one is F2 is a 0.8 times of the 50 Hz. Now let us verify whether the B maximum is constant or not. So now let us verify the B maximum. B maximum directly proportional to V1 by F ratio. B maximum 2 is equal to B maximum 1 multiplied by V12 by V11, so into F1 by F2 values. B maximum 1 is equal to V12 is 0.8 times of the 230 volts divided by 230 and F1 is a 50 Hz, 0.8 times of the 50 Hz and 230 cancel, 50 also cancel, 0.8. So that B maximum 2 is equal to B maximum 1. When B maximum is constant, then what will happen? So when the B maximum is constant, so we know that hysteresis loss directly proportional to the frequency, whereas eddy current loss directly proportional to square of the frequency. And from here we can get WH2 is equal to WH1 multiplied by F2 by F1. So F2 by F1 means WH1 is hysteresis losses of the transformer 100 watts. The F2 is equal to 0.8 times of 50 Hz divided by 50 Hz. 50 is cancelled and it is equal to 80 watts. Eddy current losses is equal to 80. And this value WE2 is equal to WE1 multiplied by F2 by F1. So it is WE1 is iron loss, eddy current losses equal to 50 whole square. So 50 into 0.8 times of 50 divided by 50 whole square and 50 is cancelled, 50 into 0.8, 0.64 and 0.64 is 64, 6.4 into 30, 32 watts. By solving here we will get 32 watts. Is it correct? 32, 6.4 into 5. Yes, 32 watts is the right answer. Eddy current losses equal to 32 watts and hysteresis losses equal to 80 watts. So option 2 is correct for this question. And next one, question number 5. At 50 Hz operation, A single phase transformer has hysteresis loss of 200 volts, eddy current losses of 100 watts. Its core losses at 68 operation will be option 1 432 watts, 408 watts, 384 watts, 360 watts. సో ఇక్కడ ఈ క్వశ్చన్లో బీ మ్యాక్సిమం గురించి డేటా మనం కనుక్కోలేం. అప్పుడు ఏమనుకోవాలంటే బీ మ్యాక్సిమం కాన్స్టంట్ అనుకోవాలి. సో ఇన్ దిస్ క్వశ్చన్ అజూమ్ ఒక బీ మ్యాక్సిమం సో ఈజ్ కాన్స్టంట్. సో వాళ్ళ క్వశ్చన్లో మనకు బీ మ్యాక్సిమం గురించి ఏం డేటా తెలియకపోతే అప్పుడు ఆ క్వశ్చన్ సాల్వ్ చేయడానికి బీ మ్యాక్సిమం కాన్స్టంట్ అనుకోండి. సో వెన్ బీ మ్యాక్సిమం ఈజ్ కాన్స్టంట్, hysteresis loss directly proportional to the frequency, whereas eddy current loss directly proportional to square of the frequency. When B maximum is constant, then what will happen? The hysteresis loss directly proportional to frequency, eddy current loss directly proportional to square of the frequency. From here we can write the WH2 is equal to WH1 multiplied by F2 by F1 value. WH1 is 200, so into 60 divided by 50. So now this value is equal to 60 divided by 50 means, so now here 200 into so 5, so that is equal to, so 200 multiplied by 6 by 5. So we got, so now this one is 40 into, so 40 and so 40 into 6, so 240 watts. So this one is the 240 watts. And next one, eddy current losses WE2 is equal to WE1 F2 by F1 whole square, and WE1 is equal to WE1 100 watts, and F2 is equal to 6 by 60 divided by 50 whole square. So 100, so into 0 is a cancel, 36 divided by 25. So 36 divided by 25, and 25 means, okay, it is a 4 multiplied by 36, 72, that is equal to 144 watts. 144 and plus 240. So total iron losses is equal to WI2 is the WH2 plus WE2. So equal to 240 plus 144, and 240 plus 144, it is a 384 watts. So answer is the 384 watts is the correct. సో ఇలాంటి క్వశ్చన్స్ అడిగే అవకాశం ఉంటుంది ఈ కాన్సెప్ట్లో. ఎడ్డీ కరెంట్ లాసెస్ని కనుక్కోవడం, టోటల్ లాసెస్ కనుక్కోవడం, ఇంకా ఒక డిఫరెంట్ ఫ్రీక్వెన్సీ చేసి ఐరన్ లాసెస్ని కనుక్కోవడం. అప్పుడు ఏ అండ్ బి వాల్యూ సాల్వ్ చేసి అండ్ దాంట్లో సబ్స్టిట్యూట్ చేస్తే విల్ గెట్ ఐరన్ లాసెస్. అదొక మోడల్ ఆఫ్ క్వశ్చన్. మనం ఆ షార్ట్ నోట్స్లో రాపిస్తాను, హౌ టు ఫైండ్ అవుట్ ఐరన్ లాసెస్ ఇఫ్ డిఫరెంట్ ఫ్రీక్వెన్సీస్ ఆర్ గివెన్. అండ్ దిస్ ఈజ్ ద 5 మోడల్ ఆఫ్ ద క్వశ్చన్ బేస్డ్ ఆన్ దిస్ కాన్సెప్ట్. సో ఈ దాంట్లో 5 మోడల్ ఆఫ్ ద క్వశ్చన్స్ పాయింట్ ఆఫ్ వ్యూ సియర్. ఇలా ప్రతి కాన్సెప్ట్లో తర్వాత ప్రతి టాపిక్ గురించి వివరంగా వీడియో లెక్చర్స్ డిస్కస్ చేయడం జరిగింది. ఆ వీడియో లెక్చర్స్ ఎలా ఉంటాయి అనేది మీకు ఒకసారి వివరిస్తాను. టాపిక్ వైజ్ డిజిటల్ వీడియో క్లాసెస్ అనేవి ఉంటాయి. ప్రతి సబ్జెక్ట్లో ప్రతి టాపిక్లో డిజిటల్ వీడియో క్లాసెస్ ఉంటాయి. మరి డిజిటల్ వీడియో క్లాసెస్తో పాటు ఆ వీడియో క్లాస్ అంటే థియరిటికల్గా ఎక్స్ప్లెయిన్ చేయడం జరుగుతుంది. తర్వాత దాని క్వశ్చన్ సిరీస్ ఎలా ఉంటుందంటే ప్రాక్టీస్ మొత్తం ఇలా గేట్ పీవైక్యూస్, ప్రీవియస్ ఇయర్ గేట్ క్వశ్చన్స్ ఎక్స్ప్లెయిన్ చేయడం జరిగింది. తర్వాత ప్రీవియస్ ఇయర్ ఈఎస్సి క్వశ్చన్స్ కూడా దానితో పాటు ఎక్స్ప్లెయిన్ చేశాం. అండ్ నెక్స్ట్ తర్వాత జెన్కో, ట్రాన్స్కో, డిస్కమ్లో ఇచ్చిన ప్రీవియస్ ఇయర్ క్వశ్చన్స్ కూడా డిస్కస్ చేశాను. అండ్ నెక్స్ట్ తీసుకున్నట్లయితే అదర్ స్టేట్ పిఎస్యూస్ అంటే ఆల్ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్స్ ప్రీవియస్ ఇయర్ క్వశ్చన్స్ను డిస్కస్ చేశాం. అండ్ నెక్స్ట్ స్టాండర్డ్ బుక్స్ బ్యాక్ సైడ్ ఆబ్జెక్టివ్ క్వశ్చన్స్ కూడా డిస్కస్ చేశాం. ఫర్ ఎగ్జాంపుల్ పవర్ సిస్టమ్కు సిఎల్ వాద్వా క్వశ్చన్స్, పవర్ ఎలక్ట్రానిక్స్ పిఎస్ బిమ్రా, ఎలక్ట్రికల్ మిషన్ పిఎస్ బిమ్రా క్వశ్చన్స్, ఇలా ప్రతి స్టాండర్డ్ బుక్ క్వశ్చన్స్ ఆబ్జెక్టివ్ క్వశ్చన్ డిస్కస్ చేయడం జరిగింది. సో ఇలా అన్ని క్వశ్చన్స్ మరి థిరిటికల్గా ఆన్లైన్ కోర్స్ ప్రొవైడ్ చేసే సంస్థ ఏదైనా ఉంది అని అంటే అది సాయి మేధా కోటి హైదరాబాద్. సో ఈ కంప్లీట్ ఆన్లైన్ కోర్స్ని మీకు ద స్పేస్ గేట్ అనే యాప్ ద్వారా ప్రొవైడ్ చేయడం జరుగుతుంది. సో మరి ఇంత కంటెంట్ మీకు చాలా ఎక్కువ మొత్తంలో కాకుండా వెరీ లెస్ అమౌంట్ ఆఫ్ ప్రైస్లో మీకు ప్రొవైడ్ చేస్తున్నాం. ఆ ప్రైస్ ఎలా ఉంటుంది అనేది చూడండి. ఏఈ మరియు ఏడబ్ల్యూ ఎగ్జామ్స్, సపోజ్ ఆంధ్రప్రదేశ్ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్ ఏడబ్ల్యూ ఎగ్జామ్కు మీరు ప్రిపేర్ అవుతున్నట్లయితే మీకు ఆన్లైన్ కోర్స్ తీసుకుంటే, ఓన్లీ ఆన్లైన్ కోర్స్ తీసుకున్నాను అనుకోండి, కేవలం 9,000 రూపీస్లో మీకు ప్రొవైడ్ చేయడం జరుగుతుంది. మరి ఒకవేళ మీరు ఆన్లైన్ ప్లస్ ఆఫ్లైన్ రెండు వచ్చినట్లయితే మా దగ్గర ఆన్లైన్ క్లాసెస్ మరియు ఆఫ్లైన్ క్లాసెస్ కూడా రెండు జరుగుతున్నాయి. మరి ఆన్లైన్ ఆఫ్లైన్కి వచ్చినట్లయితే మీకు అది 27,000 రూపీస్లో ఇస్తాం. అంటే ఇంక్లూడింగ్ మెటీరియల్ కూడా మీకు ప్రొవైడ్ చేయడం జరుగుతుంది. అదేవిధంగా ఒకవేళ మీరు జేఎల్ఎంకు ప్రిపేర్ అయ్యే వాళ్ళు ఉంటే, మీకు తెలిసిన ఎవరైనా జేఎల్ఎం ప్రిపేర్ అయ్యే వాళ్ళు ఉంటే అది 4,900 రూపీస్ ఆన్లైన్ కోర్స్, మరి ఆఫ్లైన్ అనేది 12,000 రూపీస్. ఈ విధంగా మీకు ఈ యాప్ ద్వారా ప్రొవైడ్ చేస్తాం. మీకు జేఎల్ఎం కోసం అయితే SAIMEDHA.in అనే యాప్ ఉంటుంది. తర్వాత ఈ గేట్ కానీ తర్వాత ఏడబ్ల్యూ కొరకు ద స్పేస్ గేట్ అనే యాప్ ద్వారా మీరు డౌన్లోడ్ చేసుకోవాలి. మరి ఈ డౌన్లోడ్ చేసుకున్న తర్వాత సో ఈ నెంబర్స్కి కాల్ చేయండి, మీకు కంప్లీట్ ఇన్ఫర్మేషన్ అనేది తెలుస్తుంది. అండ్ అదేవిధంగా మీరు డౌన్లోడ్ చేసిన తర్వాత కొన్ని వీడియోస్ ప్రీ యాక్సెస్లో ఉన్నాయి. ఫస్ట్ డౌన్లోడ్ చేసిన తర్వాత మీరు కోర్స్ చూడండి ఒకసారి, ఏ విధంగా ఉంది కోర్సు, తర్వాత మేము ఎలా డిజైన్ చేసాం, ఒక పర్టికులర్గా ఒక పద్ధతిగా డిజైన్ చేసిన కోర్స్ ఇది. మీకు థియరిటికల్ క్లాసెస్, పీవైక్యూ గేట్ పీవైక్యూస్, ఈఎస్సి పీవైక్యూస్, యూపీఎస్సి పీవైక్యూస్, జెన్కో, ట్రాన్స్కో, డిస్కమ్ పీవైక్యూస్ అండ్ ఆల్ స్టేట్, ఇండియాలో ఉన్న ఆల్ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్స్ క్వశ్చన్స్, ప్రీవియస్ ఇయర్ క్వశ్చన్స్ కూడా డిస్కస్ చేసాం. అండ్ ఆల్సో స్టాండర్డ్ టెక్స్ట్ బుక్ క్వశ్చన్స్ కూడా డిస్కస్ చేసాం. సో ఈ విధంగా నీకు క్వశ్చన్ గురించి ఒక్కొక్క టాపిక్లో ఎన్నో క్వశ్చన్స్ ఉన్నాయి. మినిమం ఒక 100 క్వశ్చన్స్, ఒక్కొక్క టాపిక్ గురించి 100 క్వశ్చన్స్ డిస్కస్ చేయడం జరిగింది. అది ప్రతి సబ్జెక్ట్లో చేసాం. మీరు కోర్స్ తీసుకోవాలనుకుంటే ఫస్ట్ వెరిఫై చేయండి ఆ కోర్స్లో ఎన్ని అంటే సబ్జెక్ట్ వైజ్గా కంటెంట్ ఉందా లేదా. తర్వాత కంటెంట్ లేకపోతే ఒక 2-3 సబ్జెక్ట్స్ ఉన్నాయనుకోండి, అలా ఉండి తర్వాత మేము అప్డేట్ చేస్తామని చెప్పే కొన్ని సంస్థలు ఉన్నాయి మార్కెట్లో. అలాంటి సంస్థలకు మీరు బలి కాకండి. సో మోసపోకండి. మేము క్లియర్గా చెప్తున్నాం, మా దగ్గర కంప్లీట్ అన్ని సబ్జెక్ట్స్ చేసాం మేము కంటెంట్. సో ఈ కంటెంట్ మీరు ఒకసారి చూడండి, తర్వాత వెరిఫై చేయండి ఎంత మేరకు ఉంది అనేది తెలుస్తుంది. తెలిసిన తర్వాత మీరు పర్చేజ్ చేయండి. ఓకే, ఐ విష్ యూ ఆల్ ద బెస్ట్. ఐ హోప్ యూ గాట్ ఇట్. థ్యాంక్ యూ వెరీ మచ్.